Hello students, welcome to Husky Math. Today we will do some exercises. So here the question is asking to find the value of dy over dx when y equals to sine, and inside the sine function there is a square root of sine x plus cos x. So this is a function in a function. Okay, so here we will try to use the chain rule we have learned in the previous video. So let us start. Let t equals to root over sine x plus cos x. I'm assuming this portion to be as t. Okay, then y equals to sine of t. Also, let us assume this portion, the sine x plus cos x, as u. Okay, so let u equals to sine of x plus cos of x. So if u equals to sine of x plus cos of x, then this t can be written as, this implies t can be written as root over u. So here we can see three equations. Y equals to sine of t, that means y is a function of t, but t equals to root over u, that means t is a function of u, and u equals to sine x plus cos x, that is u is a function of x. Okay, now since y equals to sine of t, so if I differentiate both sides with respect to t, then we will have dy over dt equals to d dt of sine t, and this implies, and this equals cos of t, that means dy over dt equals to cos of t. So let this be equation 1. So also t is a function of u, t equals to root over u, that means t can be written as u to the power half. So obviously we can differentiate this equation with respect to u, so that means ddu of t equals to ddu of u to the power half. So this implies dt over du equals to half u to the power half minus 1. On simplification we will get 1 by 2 root over u. So let this be equation 2. Now finally we have u equals to sine of x plus cos of x, so we will differentiate this also. So on differentiating, so since u is a function of x, so we have to differentiate both sides with respect to x. So ddx of u equals to ddx of sine of x plus cos of x. So this implies du over dx equals to ddx of sine x is cos of x, and ddx of cos x is minus sine of x. So let this be equation 3. Now since the question was asking to find the value of dy over dx, so dy over dx can be written as, so therefore dy over dx can be written as, we have to multiply equation 1, 2 and 3, because dy over dx can be written as dy over dt, because y was a function of t, and again multiplying equation 2, that is dt over du, because t was a function of u, and equation 3, that is du over dx, because u was a function of x. So now if you notice here, then that means this dt and dt will get cancelled, and this du and du will get cancelled, so we will remain with dy over dx. So that is how the chain rule works. And dy over dt is cos of t into dt over du means 1 over 2 root u into du over dx is cos of x minus sine of x. So finally we will replace all the values of u and t. So our t means cos of root over sine x plus cos x into 1 by 2 root over sine x plus cos x times cos x minus sin x. So therefore dy over dx equals to cos of x minus sin of x into cos of root over sin x plus cos x whole divided by 2 root over sin x plus cos x. So this is your answer. Next, number 2, the function is y equals to sin x plus x square over cot 2x. Okay, so here first I will try to implement the quotient rule. Remember the quotient rule? Let me write once. Dtx of u over v. So if I have to differentiate this using quotient rule, then the formula was v du over dx minus u dv over dx divided by v square. So using this quotient rule, we will try to get the thing done. So here sin x plus x square can be considered as u and cot 2x can be considered as v. So differentiating both sides with respect to x, that is ddx of y equals to ddx of sin x plus x square divided by cot 2x. So this will be equal to according to the quotient rule, first I need to write the v, that is the denominator, cot 2x. So ddx of numerator, that is u sin x plus x square, minus, writing the numerator first and differentiating the denominator, that is cot 2x whole divided by denominator square, that is cot 2x whole square. So this will be equal to cot 2x. So ddx of sin x is cos of x plus ddx of x square is 2x minus sin x plus x square. Now differentiating this portion, differentiating ddx of cot 2x. So here we have to use the chain rule. I want you to look here. Okay, so I have to differentiate ddx of cot of 2x. Okay, first I need to know the formula of ddx of cot x minus cos x square x. Okay, so now the difference is that here instead of this particular x, I have 2x here. Okay, minus cos x square. So instead of x we have 2x, so I have to write 2x, but using the chain rule you have to differentiate the function 2x also. So this is how the chain rule works. So it will be equals to minus cos x square 2x times ddx of 2x is simply 2. So the answer for that is minus 2 cos x square 2x. Okay, so let us come back here. So that means this portion is ddx of cot 2x can be written as minus 2 cos x square 2x whole divided by cot of 2x whole square. So this will be equal to, now let me simplify this further. So obviously ddx of y means dy over dx. This is dy over dx. Dy over dx equals to cot 2x times cos x plus 2x. So here if I simplify, it will be plus 2 cos x square 2x sin of x plus x square whole divided by cot of 2x whole square. So my answer can be written in this format also, but if you simplify, then you will be getting a simpler answer obviously. So let me distribute the denominator, so it can be written as cot of 2x cos of x plus 2x divided by cot of 2x whole square plus 2 cos x square 2x sine of x plus x square divided by cot 2x whole square. So obviously here cot 2x and this square will get cancelled, so this can be written as cos of x plus 2x divided by cot 2x plus 2. Now cos x square 2x can be written as 1 by sine square 2x into, now cot 2x whole square can be written as cos square 2x divided by sine square 2x. Okay, so here it is 1 into sine of x plus x square. So here sine square 2x get cancelled, so therefore dy over dx equals to, now cot 2x can be written as tan 2x cos of x plus 2x plus 2. 1 over cos square 2x can be written as 6 square 2x sine of x plus x square. So this is the simpler form, okay, but you can keep your answer up to here also. Number 3, if y equals to cos of x minus sine x over cos of x plus sine x, show that dy over dx plus y squared plus 1 equals to 0. So here we need to prove this equation. So for that I need to find first the value of dy over dx, okay, and the value of y is given in the question only, so just we have to square that term plus, and we have to add 1, and doing so we have to get the value as 0. Okay, so first let us differentiate the given function with respect to x, because we need the value of dy over dx in the question. Okay, let us differentiate the given function using the quotient rule. So differentiating both sides with respect to x, ddx of y equals to ddx of cos of x minus sine of x whole divided by cos of x plus sine of x. So this implies dy over dx equals to, using the quotient rule I have to write the denominator first, so that is cos of x plus sine of x, and differentiate the numerator, that is ddx of cos of x minus sine x minus, write the numerator first, cos x minus sine x, differentiate the denominator, ddx of cos of x plus sine of x, and whole divided by cos of x plus sine of x whole square. Cos of x plus sine of x, ddx of cos x is minus sine x, minus ddx of sine x is cos x, minus cos of x minus sine of x, ddx of cos x is minus sine x, plus ddx of sine x is cos x, whole divided by, so let me write sine x plus cos x here, okay, sine x plus cos x whole square. Now let us simplify it further. So here in numerator, from the first term, let me take out minus common, so it will be minus, and let me write this cos x plus sine x as sine x plus cos x, and since we have taken out the minus common, so here it will remain with sine x plus cos x minus, so here let us take out minus common from both the brackets, so it will be minus of sine x minus cos x, and from here also let us take out minus common, so it will be sine x minus cos x whole divided by sine x plus cos x whole square. So we are getting the value of dy over dx. So let me simplify it further, okay? So because at last it will be easier for us. So here, as you can see, that sine x plus cos x times sine x plus cos x can be written as sine x plus cos x whole square. So minus, and since here in both from the bracket we have minus and minus, so they will get eventually plus, so no need to change the sign here. So sin x minus cos x and sin x minus cos x will be sin x minus cos x whole square, whole divided by sin x plus cos x whole square. So let me simplify the numerator. So what we will do is we will expand this two terms using the a plus b whole square and a minus b whole square. So here it will be minus a plus b whole square, a square plus b square plus 2ab minus, here also we will expand using the formula of a minus b whole square. So it is a square plus b square minus 2ab whole divided by sin x. Okay, here also let us just expand this a plus b whole square. So it will be a square plus b square plus 2ab. Okay, now since we know the value of sin square plus cos square x is 1, sin square plus cos square x is 1, and sin square plus cos square x is 1, so we will write minus 1 plus 2 sin x cos x. See, here we are doing by step, okay? So it might seem lengthier, but eventually after your practice you can do it directly also, okay? So but for understanding purpose I am doing it slower here, okay? So minus 1 minus 2 sin x cos x whole divided by 1 plus 2 sin x plus, not plus, sin x cos x. So therefore dy over dx can be written as minus 1 minus 2 sin x cos x minus 1 plus 2 sin x cos x whole divided by 1 plus 2 sin x cos x. So here this minus sin x minus 2 sin x cos x plus 2 sin x cos x gets 0. Dy over dx as minus 1 is minus 2 by 1 plus 2 sin x cos x. So this is the value of dy over dx. But the question was not just to find the value of dy over dx. In fact, we have to prove this equation which is given here. So dy by dx plus y square plus 1 equals to 0. Now since till now I have found the value of dy over dx, now let us find the value of y square. So in order to find the value of y square, I just need to square the given function, that is, let us square this function, so we'll get y square. Okay, till now we have found the value of dy over dx. Now we will find the value of y square. Okay, so since y is given already, so here y square means to square this fraction also, cos x minus sin x by cos x plus sin x whole square. So if I simplify it, it will be cos square x plus sin square x minus 2 sin x cos x whole divided by cos square x plus sin square x plus 2 sin x cos x. So it will be 1 minus 2 sin x cos x divided by 1 plus 2 sin x cos x. So this is the value of y square. Now we will add all the thing here. Okay, since we have got the value of y square also, that is 1 minus 2 sin x cos x by 1 plus 2 sin x cos x. Now we will write this equation the left hand side, and we will show it equals to 0. So let us write this equation here. So let's write left hand side. So that is dy over dx plus y square plus 1. So this will be equal to, since we know the value of dy over dx, that is minus 2 by 1 plus 2 sin x cos x plus the value of y square is 1 minus 2 sin x cos x over 1 plus 2 sin x cos x plus 1. So now let us simplify it. So obviously here we will take the LCM. So the LCM of these three fractions, this denominator will be 1 plus 2 sin x cos x, and in numerator we will have minus 2 plus 1 minus 2 sin x cos x plus 1 plus 2 sin x plus sin x cos x. So here, as you can see, plus 2 sin x cos x minus 2 sin x cos x get cancelled, and plus 1 will get a plus 2, that will cancel with minus 2, and hence we are getting 0 by 1 plus 2 sin x cos x, which will be equals to 0, and that is our right hand side, hence proved. Question number 4. If y equals to root over sec x minus tan x over sec x plus tan x, then so that dy over dx is sec x times tan x minus sec x. So answer is already given, just we need to differentiate the given function. We need to get the answer provided by the question, so we need to show that, we need to prove. So let us differentiate both sides with respect to x. So before differentiating the given function, let me simplify the given function first before differentiating. Okay, so here before differentiating, let me write the value of sec x as 1 over cos x minus tan x can be written as sin x over cos x whole divided by, similarly in denominator also, 1 over cos x plus sin x over cos x. So this will be equal to root over, let us take the LCM in numerator, so it will be cos of x, and here it will be 1 minus sin x, and whole thing divided by, in denominator also let us take the LCM, it is cos of x, so here it will be 1 plus sin x. So here we can see that this cos x and this cos x are getting cancelled. So here it will be equal to root over 1 minus sin x by 1 plus sin x. Now let us rationalize the denominator. Okay, so in order to rationalize the denominator, let us multiply with a fraction 1 minus sin x divided by 1 minus sin x. So doing so, we will get y equals to root over 1 minus sin x whole square divided by 1 square minus sin square x, because that is the product of sum and difference of the same thing. So here it will be root over 1 minus sin x whole square. I am distributing the square root to both numerator and denominator. So here in denominator we have 1 minus sin square x, and 1 minus sin square x can be written as cos square x. So here if I cancel the square with the square root, square with the square root, then we will have 1 minus sin x by cos x. Now my function seems simpler. Okay, so before differentiating we have made the function simpler. So let me write that everything here. So here this y can be written as 1 by cos x minus sin x over cos x. So this implies y equals to 1 by cos x can be written as sec x minus sin x over cos x can be written as tan x. So differentiating both sides with respect to x, we will have ddx of y equals to ddx of sec x minus ddx of tan x. This implies dy over dx equals to ddx of sec x is sec x tan x minus ddx of tan x is sec square x. So if I take out sec x common from both the terms, then we will have sec x times tan x minus sec x, hence proved. So this was the equation which we have to prove. So with this we have completed the differentiation part. So I recommend you to watch all the videos of this differentiation and practice more and more from your exercises. Okay, so this is the end of this differentiation.